All right, welcome, AP. We're here to talk about continuity. Now, you've already watched some videos through Khan Academy discussing continuity, and this is going just a little bit further, getting a little more personal with the instruction. Okay, so this quick video is in regards to the general idea about continuity, building off of what you read and viewed already. Okay, so we can say that a function is continuous at a point if the limit as x approaches a of the function is equal to the value of the function at that point. Okay, basically here's the idea. We know that a limit is talking about what's happening to a function as x gets very close to a particular value. Okay, so let's make a quick little graph right here. All right, and here's my point A. That's x equals a right there. So the limit as x approaches a, that's checking out what happens as the function, through the function as x approaches a from the left side, and also what happens to the function as x approaches a from the right side. And if the two values are heading towards the same number from both the left and the right, then the limit will exist. But the limit itself does not actually care about what's happening at x equals a. It only cares about what's happening as x gets closer and closer and closer to a. However, if we want the value of the function as x approaches a, then we actually plug a into the function. And if when we plug a into the function, we get the exact same value as the limit, then what ends up happening is we get to fill in that dot right there. And therefore, we have a nice continuous function where the marker never leaves the board. All right, we think about the definition of continuous in general. We know that something is continuous. It just keeps going and going and going. And that's what we have here with our function. It just keeps moving right along. There's no interruptions at all. Okay. If there is an interruption, then we say the function is not continuous. But more distinctly, the function has a discontinuity at that point. So if there's a case where the limit as x approaches a of the function does not equal the function's value, for a couple of reasons, which we'll talk about in the next video, then what we're looking at is a discontinuity. Okay, but discontinuity can present itself in a bunch of different ways, which again I'll show you in future videos. But the big ones basically that we're looking at are vertical asymptotes, jumps, or holes in the graph. Okay, so very briefly, we know what a vertical asymptote is from pre-calculus. Right, that's when we're talking about a function where we have something like that. We had to have a vertical asymptote when x is equal to a. Okay, a jump is basically discussing the function when we have the function happening in some point and then it jumps down here and continues onward. If we're looking at the third type of thing where there's a hole in the graph, now we have a situation almost like what we were dealing with before, where the limit might exist, but we have that one hole there where the function is not defined at x equals a. All right, so that's situations where in every single one of those cases, I have to pick my marker up off of the board in order to complete the graph. Okay, so we can say that a continuous function can be drawn without taking your marker off the board, without taking your pencil off the paper, without removing your pencil from the paper. If you can draw the graph of the function without removing your pencil from the paper, then you have yourself a continuous function. Okay. And then last but not least for our setup here, just so you know that a function, we're going to say is continuous on an interval, okay, if it's continuous at every single point in that interval. So that seems like, okay, well, we have to check the continuity at every single point. Well, there's all these points on this particular interval. So really what we're going to focus on more so is not where the function is continuous, where the function has a discontinuity. It's easier to find those values than it is to check every single point on that interval. All right, so the future videos that we discuss will go through those notes that you have in front of you to help get you ready for this idea of continuity.